Hello, friends and students. Welcome back once again to my channel. All right. So today we'll be discussing one more newly built project, that is full-duplex Li-Fi text communication system that will be working two ways: transmission as well as reception. How it will work, what are the codes, everything will be shared and we will discuss. So let's start with the slide and we'll go to the next slide. At the same time, I will show you the videos also. All right. So let's go to the slide now. Okay. First comes the abstract. So you have to understand what is the abstract and what we are going to discuss in this particular project. The project demonstrates a bidirectional light fidelity. Li-Fi stands for light fidelity. Communication system using two Arduinos, microcontroller, enable real text time text transmission. Text transmission. Please remember it's a text transmission. Of course, we can send sound also. Text transmission via visible light. So how through a light, visible light, you can send that text information from both the sides. So that we are going to see. Okay. Now, what are the components required? That's with the photographs I have given it here. We need two Arduino boards for transmission, reception, receiving side. Two keypads, data transmission. Then LED for data transmission, LDR to see on the with the text has come. We need a display, that is I2C, two LCD 16:2 display, and few register I have used that here. So what I will do is at the same time I will show you the videos also. Okay, the setup of the videos also we can see. All right. So I will just same time I will explain you about the things and all. So these are the two keypads, right? Two Arduinos I have used. This is Arduino number. So just imagine this is Arduino number 1. And this is Arduino 2. Okay. When I have used Arduino, another one I have used as Arduino Nano. There are two displays here, 16:12 display. Two LEDs. Please remember how I have kept it. One LED and one in front of the LDR. Another LED coming from this side to the LDR. So keypad, microcontroller, I have just arranged it on the breadboard, two separate breadboards and two separate microcontroller. And I have given power supply from here. You can see, I will just try to show it to you. From here, computer, I'm just giving through data cable, two data cables, I am giving the power supply. This two data cables, I'm giving the power supply. So I'm just showing you the setup here. Okay, right. Now, we'll go to the next slide about the project description. Okay, what is the project description? So the setup consists of two identical Arduinos, each capable of transmitting and receiving both. Okay, both the things will be done, transmission as well as receiving, because I just shown you there is a transmission as well as there is a receiver also. And binary, how it will go, transmitter and receiving, it will be going through the binary lines. Okay, light displays will display all that information. That is the binary codes. It will be encoded first, then decoded first with the help of this circuit. I will just explain you, and then it will be displayed on the two LCD. So this is the basic system overview. All right. So we'll go to the next slide, please. Okay. What are the key features? It's a two-way communication. You have to remember, duplex means two-way communication. Each node can send and receive data simultaneously, right? Simultaneously, we can send and receive data. Half duplex implementation. So that is one side only, we call it as half duplex. Okay. I2C interface we have connected. That means this two display I2C interface we have connected. Simplified wiring using LCD display. That means you'd use only four wires here. Okay. Only 4 wires. SCL, SDA, and you have 5V and ground. That's all. Both the same. We don't have to go for a 16 number of connection or here. Okay. Right. For error resistance protocol, start, stop, synchronize data, we have given some codes to that. Okay. User-friendly interface. Keypad is there for this thing. You just press it and you send it. Okay. Right. Now, we'll go to the next slide and we'll see. Okay. Right. Working principle. So what is the working principle of this? You have to understand, because working principle is very important. So I will just show you. Transmission mode. You have to enter first display. That is, if this is the transmitter, then you have to enter the display. This will be, we have to give the display into this. If this is the transmitter, then you have to give information to this keypad. Okay. So separate keypads for that. Arduino encode each character. Okay. In 8 bits. 8 bit it will encode in the binary format. Data is transmitted as a light pulse using a LED. Okay, these are the LEDs for the for data transmission, right? Which will be pulsing, giving the light pulse. Okay, I will just show you. Suppose I'm sending here light pulse. I'm just in this. I'm sending one light pulse, and I'm press 1. You can see 1 has come over here, and I'm sending it. You have to press hash for that. Okay, so you can see light pulse will be there, and it will reflect here, or it will come to this thing. 1 number has come over here. Whatever I have pressed through light, it has come over or on this. Okay. So same thing, we'll try it from this side also. So suppose I am pressing 2 number here. So 2 number, I will just try to show it to you. whether you can see it or not, or I don't know. So this is number 2 here. Okay, 2 number. I'm trying to set hash. I have to press it hash. So 2 number, and I have to press hash. So you can see here now it has transmitted. I press 2 digits here. Let's see whether it comes over here or not. Yes, you can see here that this thing has come. Okay, right. But it will be there for some time only. So this indicates how we can transmit through light. Okay. So LDR receives it. 2 LDRs are there on this side and that side. And LDR is for receiving. So 2 LDR will be detecting light frequency. Arduino measures analog voltage frequency. Please remember PWM frequency. Why we use these 2 boards, microcontroller, it will convert, it will measure, right, and reconstruct, and it will show it on the LCD, both the LCDs. Okay. Suppose you want to remove it, then you have to press this star button here. Everything will be cleared out. Okay. Right. Okay. So this is about the working principle. Now, what are the software implication? I will share the software also. That is the codes. Both the end, you have to put a single code only. Same codes on both the ends. Okay. So codes for transmission, receiver, it's not different. It's single code for transmitter also and for receiver also. Okay. Application, where it is used to data, military, hospital, aircraft, you can just think of the projects, what you can do. Underwater communication, educational demo, optical, wireless technology. Optical, wireless. Optical is light. So wireless technology in that. Industrial IoT, EMI sensitive environment. Okay, that is where this thing will be not disturbing. Okay, now advantage over RF. What is the advantage over RF? This thing, no electromagnetic interference, because we are not dealing with the electromagnetic, because we are dealing with the lights. Okay, optical lights, high security signal confined to light path only, license free operation, work in RF restricted zone. So this diagram. So this is the signal flow, and I've shown it for transmission and receiver. So first keypad, you enter Arduino encodes the text. First keypad to Arduino to LED. The light pulse is shown on the LED. Then through air, medium is air only. Please remember the medium is air, and it is received by the LDR other station. That is the other side. So this is the way how the flow works. So reception also same, right? Reception also it will be same. Like LDR detects light, Arduino decodes. First we have encoded another this thing, it will be decoded. I2C LCD displays the message, whatever the message or whatever the information you have sent from one side, from suppose this side, I'm sending one information from this side, and you can send whatever information, it will be displayed on this. Okay. So it will be displayed on this thing. You can see one, it has come, and immediately it will go. It will also show input, whether it has received the input or not. Everything will be shown on this. So this is the schematic diagram, rough schematic diagram I have made. I will share this. You can just copy it down, which pin is used and how it has been used. Okay. Now conclusion. In the conclusion, the project successfully implemented a low-cost full duplex. Low cost. Please remember, it's not very costly. This thing, full duplex Li-Fi system using Arduino. Demonstrating particle visible light, right? Visible light. Okay, right. Communication. Further enhancement could be include high data rate, right? Using PWM. We can send more data using PWM. Okay, optimization, error correction, noisy environment, multi-node networking support. Design provides a foundation for secure local area operation, communication with application in IoT, defense, and industrial automation. So please remember, we can use this in IoT, defense, and industrial automation. So 2-3 drawbacks are there. I'll just tell you. One, I have put it a very dark. It is working with a light. A lot of light is there because I have to take the picture and all. So a lot of light will be there. So in this environment, please remember, this thing will be there. So if it is dark, so if you want that the distance should be more, then it should be dark area. The sound surrounding should be dark, because only light, and there should not be any other light disturbance. If suppose another light disturbance is coming, so that will be disturbing this light. So if it is conical shaped or pipe shaped, this thing will be there. It can travel up to long distance. So please remember this. I'm just showing you once again. So how it is working, you can just see from here. I'm sending, it will be received here. You can see 4 number. I have pressed here, 4 number. It is here. So I will just press, say about 5 number here, and I will just show it to you. I have pressed 5 number, and you can see whether we are getting 5 number here or not. You have got it. Okay. So the distance is approximately very few, maybe 3-4 centimeters. We can go. You can try with up to 10 centimeters also. So these things you have to understand. We will run both the things with the battery. That is 5 volt. We put a 5 volt regulator here, 5 volt regulator here, and it will work automatically. Okay. One more idea. I've just got it. I will just share with you. This can be used as a security system also. So if anybody's there on the door, if anybody tries to open the door, the sensors will, the LDR will go, the light will enter, fall, and the information will come onto the screen, both the screens. Okay. So if you want to remove, suppose here it is showing 5. So if you want to remove it, you have to press your star. Okay. I'm removing it. Okay. So likewise, you have to do it. Everything, all the information I will be sharing with you. Codes I will be sharing with you. I have the codes and all. This is Light Duplex. I know. So these are the 3 libraries. That is keypad edge. Okay, these are the 3 libraries: wire and liquid crystal I2 switch. Okay, so accordingly, the first thing we have to select the libraries. Then rows and columns we have to give about this thing. Whatever the keypad you are using, you have to show the rows and columns about that. Okay, so what are the pins we have used for that? 6, 7, 8, 9 for rows, and 2, 3, 4, 5 for columns. So we have just shown it here. Keypad makes and all, you can just give it here. So it's a what is the address? It is 0 into 27. Okay, 16 into 2 cross LCD we have used. Okay, we have defined the pins also, the LED pin and the LDR pin. Okay, so this is very important. Please remember this threshold is very important. Why? Because threshold is nothing but the intensity of light and pulse. So you can just change this threshold, adjust. You can adjust this threshold according to your requirement, because it depends upon the LED and the LDR what you are using. So rest of all this thing, output and input, we have shown it. Li-Fi duplex, what LCD should print. You can change whatever you want, the name and all you can want from here, and it works on a 9600 baud rate. Keypad, whatever you message you press, accordingly it will be displayed. That is the given to this particular thing. Okay, so this is input and this is the transmission side. We have given it. This is the transmission side. What happens with this message, high and low, how it becomes, and it will be shown. Okay, part read 8-bit data. This is very important part. If you do know about, will in some other case we'll discuss about these things, and again it will restart the program. Okay, so numbers and all what you have to press. Once again, I will tell you again. So number system, you please remember, hash is for sending, and star is for clearing. Okay, star is for clearing. So hash is for sending and star is for clearing. Okay, so that you have to keep it in mind. All right. So that part it does come now. Okay. So from this, first we have to remove the number. You have to press star. Okay. Then I will press, say, about 5 here. Okay, 5, and I will just send it. Okay. Let's see. Yes, it has come now. Okay. So let's try 0 from here. Send. Yes, 0 has come over here. Okay. So likewise, little loose contact maybe. If we assemble on the PCB board, it will be permanent light, and we can just face it because this distance is very important. External light is very important. So that is the reason why it was not working properly. But this is the working model. Okay. So successfully we have completed it. I hope you like this project. If you like the project, if you want anything else, if you want some more information on the project, please let me know. Please give us a comment and subscribe to my channel. Thank you very much. See you in the next project series.